The future of our planet is in our hands. The consequences of climate change are observed across the world with heat waves, wildfires, and rising sea levels. The importance of communicating how our climate is changing has never been more urgent. Climate change communication happens through peer-reviewed publications in scientific journals. These are hard to understand if you're outside the field of expertise. There's so many, it's hard to know where to start. And it can be a slow process. Months and years can pass before a publication is accepted, so the data is quite old. Arctic Basecamp are a science communication platform whose goal is to speak science to power. That is, policymakers and CEOs at Davos, for example. Their focus is communicating how the Arctic is changing to provide risk alerts on the consequence of inaction. I'm Sarah Flatters, and my task was to create an anomaly detection system to support Arctic risk alerts. The Arctic climate normally rotates in freeze and thaw cycles. Thus, detecting anomalies can provide evidence of climate change. The focus was Greenland, because the loss of Greenland's ice sheet would have devastating consequences, increasing global sea levels by 7 meters, impacting a quarter of the world's population. How can we assess the degree of Arctic melt? Well, looking within Greenland's ice sheet at melt lakes and holes for abnormalities is an expensive, difficult, and dangerous business. Alternatively, and more safely, the degree of melt can be assessed at the coast. In West Greenland, there is a town, Kangaluswak, that sits on the banks of the Watson River, which is a focal point for climate scientists. Because the Watson River drains a huge ice sheet area. And also sensors at Kangaluswak's bridge provide the daily river discharge measurements during the melt season. There were 2 key questions to answer in this project. What is the expected discharge of the river? And then also how to define an anomaly. We know that expected discharge would look like this, and a clear anomaly occurred in 2012 when high river discharge destroyed the bridge. But how can we determine what expected discharge is in data terms? Firstly, I calculated the total discharge from the river for each year. Then, an unsupervised machine learning technique, K-means, provided an unbiased way to define low discharge years and high discharge years. Examining only the low discharge years provided the expected daily river discharge. The dark blue line is the average expected discharge for each day of the melt season. With a statistical approach, the distribution of the expected discharge was defined. The upper limit of this distribution, indicated by the pale blue line, acts as the anomaly threshold for each day. Knowing the expected daily discharge, anomalies can then be identified. New data is compared to expected discharge metrics. If the data is less than the anomaly threshold, the orange crosses, then it is not anomalous. However, if the data exceeds the anomaly threshold, it is labeled as anomalous, indicated here by the red crosses. The system then communicates anomaly metrics, the size of the anomaly compared to the expected average discharge on that day, and the upper limit on that day. Finally, the system produces a data file of these metrics. So what's the impact and value of this work? Well, it's 4-fold. We can now detect when an anomaly has occurred. High river discharge in June is important to know, as this indicates early melt and likely permanent ice loss. This system defines the expected discharge pattern of the river during the melt season, which was previously unknown. Also, the size of the anomalies are defined. With this information, Arctic Basecamp can then communicate real-time Arctic risk. It's feasible to extend this anomaly detection system to rivers in East Greenland and also in Canada. Finally, the expected discharge patterns identified in this work will aid anomaly detection in Arctic temperature and snowfall datasets. Thank you to faculty and Arctic Basecamp for this fantastic experience and for you for listening.